we want to use the Newton-Raphson method to find one of the roots of the equation x to the 5 minus 3x plus 1 equals 0. It has a root somewhere between x equal 1 and x equal 2. Alright? Now, x equal 1 and x equal 2. You might even be asked to verify whether it has a root between x equal 1 and 2. How do you know this? Here, if you say f of 1 is equal to 1 to the 5 minus 3 times 1 plus 1, that would be 1 minus 3 plus 1 equal negative 2 plus 1 is negative 1. And then f of 2 is equal to 2 to the 5 minus 3 times 2 plus 1 would be 2 to the 5 is what? 2 2 is 4, 4 2 is 8, 8 2 is 16, 16 2 is 32. So you have 32 minus 6 plus 1, so minus 7, which would be 32 minus 7 would be 20, 32, 23, 4, 5, 25 with 25. So the fact that the answer, one of them is negative, the other one is positive, means that the line has crossed the x-axis, so there is a root there. Suppose this is the x-axis. Let's say your y-axis is here. You go from f of x is negative 1 to f of x is 25. So it had crossed somewhere from negative 1 up to 25. So the root would be right here. Alright? This would be 1 and this would be 2. Alright? But anyway, what we want to do is to find that root to two decimal places. We're going to use the Newton-Raphson method. Now, it has a root between 1 and 2. Let's estimate that the root is at 1.5 and see what happens. So, our x1 is equal to 1.5. What is our x2? It's 1.5 minus f of 1.5. This would be, oh, by the way, let's write down f of x and f prime x here. So f of x is equal to x to the 5 minus 3x plus 1. And f prime of x is equal to 5x to the 4th minus 3. Alright, so x2 is going to be x1, which is 1.5 minus. Then 1.5 to the power of 5 minus 3 times 1.5 plus 1 divided by 5 times 1.5 to the power of 4 minus 3. So x2 would be 1.5 minus. Minus what now? Let's see. We want to, oh no, what's going on? Why did it jump off here? What's going on? Hold on there. Keep jumping off the screen. Not sure why this is happening. Alright, let me close the calculators here and open another calculator. I don't know why that thing is misbehaving like that. I want it in scientific mode. Alright, let's use this calculator. 1.5 to the power of 5, 1.5 to the power of 5 minus 3 times 1.5 minus 3 times 1.5 plus 1 equals, okay, it's 4.09375 over what now? So we divide by 5 by 1.5 to the 4 minus 3. So 5 times 1.5 to the power of 4 minus 3 close bracket equal. We have 0.183. Then 1.5 minus that. 1.5 minus that equal. We have 1.3165. 1.3165. Okay. Oh, equal. This is equal to 1.3165. That's x2. Now, suppose we consider x3 is equal to x2, which is 1.3165 minus 1.3165 to the 5 minus 3 times 1.3165 plus 1 divided by 5 times 1.3165 to the 4 minus 3. So x3 equals, let's use our calculator to get that one as well. Okay. Now, 1.3165 to the power of 5. So 1.3165, we don't necessarily have to use so many decimal places though. But to the power of 5 minus 3 times 1.3165 plus 1 equals, we have that, then we divided by open bracket 5 times 1.3165 to the 4, 5 times 1.3165 to the power of 4 minus 3, let's close the bracket, equal, that's what we have, and then 1.3165 minus that, 1.3165 minus what we have here equal. So we have 1.23288, 1.23288, 1.23288. Okay, that's x3. Now x4, if we even go closer, x4 is 1.23, call it 29 or 288, no problem, minus 1.23288 to the power of 5 minus 3 times 1.23288 plus 1 divided by 5 times 1.23288 to the power of 4 minus 3. Alright, so x4 is equal to, then we use our calculator again to work that out. So what we have, 1.23288 to the power of 5, 1.23288 to the power of 5 minus 3 times 1.23288 plus 1, that's what we get, divided by open bracket 5 times 1.23288 to the power of 4 minus 3, close bracket, equal, alright, and 1.23288 minus that, 1.23288 minus what we have there, 1.215, let's say 1.21537, 1.21537, okay. Now we could do another iteration to x5. x5 is equal to 1.21537 minus, and we have 1.23215 1.21537, 1.21537 to the 5 minus 3 times 1.21537 plus 1 divided by 5 times 1.21537 to the 4 minus 3. Remember, it's asking you for only 2 decimal places, so you would need to use so many decimal places, but use at least 3, right? Because it's asking you for 2. Now, x5 is equal to, it's going to be 1.21537 minus this that you will calculate here. So let's get our calculator. Oh no, let's close off where we have our calculators here. Let's go back to our screen. Alright, let's try getting our calculator again. Okay, we have a calculator here, so what we have here, 1.21537, 1.21537 to the power of 5 minus 3 times 1.21537 plus 1 is equal to 0.0057. Alright, put that over open bracket, 5 times 1.21537 to the power of 4 minus 3, close bracket, equal, okay, then 1.21537 minus that equal, 1.214, 1.214. Okay, so you had x4 as 1.22 decimal places. X4 would have been 1.215, but 1.22 here to 2 decimal places. This would have been 1.22 to 2 decimal places. X5 would have been 1.21. So if we make one more iteration, x6, you will have 1.2146 minus, then 1.2146 to the 5 minus 3 times 1.2146 plus 1 over 5 times 1.2146 to the 4 minus 3. Alright, so let's do that as a last iteration. So remember, that what we have here is the previous minus f of the previous x divided by f prime of the previous x to get the new x that we want. Alright, so let's use our calculator to do one more iteration. So we have 1.2146 to the 5, 1.2146 to the power of 5 minus 3 times 1.2146 plus 1 gives us negative 0.000378. We put that over 5 times 1.2146 raised to the power of 4 minus 3 close bracket equal, we get that. And then this will be 1.2146 minus this equal 1.214648. So x6 is equal to 1.214648. Okay, so you didn't have any change in the first two decimal places, so you can be confident that what you have is 1.21 as the required answer. So what you have is that the root is at 1.21. Now it would be interesting to see what would happen if we substitute 1.2146 into this function and see if we get 0. So 1.2146 to the 5, or how close we will get to 0, I should say, minus 3 times 1.2146, 1.2146 plus 1 equal. Alright, so if we have a correct answer here, we should get a value that is very, very close to 0. Alright, so let's see how this goes. 1.2146 to the 5, so 1.2146 raised to the power of 5 minus 3 times 1.2146, so minus 3 times 1.2146 plus 1. Alright, this is what? That plus 1 equals close to 0. Negative 0.000378 and so on. Alright, so negative 0.000 or negative 0.30379, negative 0.30, and then we have 379. Now it would be interesting to see what the graph looks like. Right? We have negative 1.2146. Okay, so let's look at the graph. Where's the graph now? Alright, I had already plotted the graph of this function, right? We have 3 roots here. Now, the root between 1 and 2 is this one. We had a root. We said that the root was between 1 and 2. There was a root between 1 and 2. Oh, the one that we found here is 1.2146. Quite close. So this one is what we're concentrating on. So let's see if we can zoom in into the graph and see what the root looks like. We can see that it has passed 1.2 a little bit, and as we zoom in, we see 1.2, 1.22. It should be 1.21 and a little bit more. Alright, so as we zoom in, we can see the value closer and closer. 1.214 and a little bit more. Alright. If you're using a phone, you might not be able to see these small numbers, but if you're using a computer, yeah, or a large tablet, then you could see them. 1.2146 is here. 1.21465. But you get the idea, right? It's an accurate value, right? Very, very close value to the real root, the true root that we're looking at. Okay, so we found our root. I'll see you in the next video.